Dear students, welcome to my channel. Today we are going to discuss about two important topics: empirical formula and molecular formula calculation. And this is very important for numerical problems, and this is the second video of stoichiometric calculation, stoichiometric chemistry. I hope after this video these topics will become clear to you all. So without wasting any time, let us begin with empirical formula and molecular formula. Let's go. So, molecular formula is the chemical formula which represents the actual number of atoms of each element present in a molecule of the compound. That means, in a compound, molecular formula represents the actual number of each constituent elements. Now, let us take an example such as glucose. The molecular formula of glucose is C6H12O6. Here the constituent element is carbon, hydrogen and oxygen. And in one molecule of glucose there is 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. That is, the actual number of carbon, hydrogen and oxygen in glucose molecule is 6, 12 and 6. And by with the help of 6, 12 and 6, we can write the molecular formula of glucose. That is the molecular formula. Similarly, the molecular formula of sulfuric acid is H2SO4. That is, number of H atoms is 2, number of sulfur atoms is 1 and number of oxygen atom is 4. Where empirical formula is the simplest whole number ratio between the atoms of the elements in the compound. That means, in glucose, we have said earlier that the molecular formula of glucose is C6H12O6. That is the molecular formula of glucose. Now, what is the empirical formula of glucose? Here, number of carbon atom is 6, number of hydrogen atom is 12, number of oxygen atom is 6. So, what is the simplest whole number ratio of this 6, 12 and 6? That is 1, 2, 1. That is the simplest whole number ratio of 6, 12 and 6. And now, by applying these 1, 2 and 1 in the constituent atoms carbon, hydrogen and oxygen, we get C1H2O1 or CH2O. That is the empirical formula of glucose. Okay? Molecular formula is the actual number of atoms and empirical formula is the simplest whole number ratio of that atoms. What is the empirical formula of hydrogen peroxide? Molecular formula of hydrogen peroxide is H2O2. Here number of H atoms is 2, number of oxygen 2, simplest whole number ratio is 1:1. So, the empirical formula of hydrogen peroxide will be H1O1, that is HO. Okay? But always molecular formula and empirical formula always not will be different. They can be same, such as in water. The molecular formula of water is H2O. Here number of H atom is 2, number of oxygen is 1. The simplest whole number ratio of 2:2 and 1 is also 2:1. That is, empirical formula of water is also H2O. That is, molecular formula of water is H2O and also empirical formula of water is also H2O. Okay? In exam, if a question arises, which compound has molecular formula is 2 times of its empirical formula, then the answer will be H2O2. Okay, HO whole suffix 2. And which molecular formula is 6 times than empirical formula? That is glucose, C6H12O6, that is CH2O whole suffix 6. Okay. So we can write molecular formula is equals to empirical formula whole suffix n. We can write where n is any positive integer. It may be 1, 2, 3 and so on. Okay. Now we are going to calculate the empirical formula and molecular formula of any compound. To calculate empirical or molecular formula, at first we have to know the percentage composition of each element, each constituent element of that compound. In previous video, I have taken a lecture on percentage composition. Now it will be very helpful. Okay. First example, a compound of carbon, hydrogen and oxygen contain 40% carbon, 6.7% hydrogen and 53.3% oxygen. That is, percentage composition is given in the problem. Now we have to calculate empirical and molecular formula of that compound. Here one information is given that its vapor density is 30. Okay. To calculate molecular formula, one information is necessary, such that if its vapor density or something else, that will be next example we can see. Now at first, to calculate empirical formula, we have to divide the percentage composition of each element with its own atomic mass. So here percentage common carbon 40 and its atomic mass 12, therefore 40 by 12. In case of hydrogen, 6.70 percentage composition, atomic mass 1, that is 6.70 by 1, and in case of oxygen 53.5 divided by 16. We get, by dividing, we get 3.33, 6.70 and 3.33. Now the smallest number is among these three numbers is 3.33, and we have to divide each number with the smallest number, that is 3.33 divided by 3.33, 6.70 by 3.33 and 3.33 by 3.33. Okay. By dividing we get 1, 2 and 1. Okay. Therefore we can write the empirical formula of that compound is C1H2O1. Okay. By this way we can calculate empirical formula very easily. Now one more part, that is molecular formula, has to be calculated. For this calculation, another information, vapor density is 30 of that compound is, we know that molecular weight of any compound is double of vapor density. We know, as vapor density of that compound is 30, therefore molecular weight will be 2 into 30, that is 60. Okay. As we get the empirical formula is CH2O. Now let us consider the molecular formula of that compound is CH2 whole suffix X. As I have said that in this video before that the molecular formula is empirical formula whole suffix N. Okay, so let us consider the molecular formula of that compound is CH2 whole suffix S. Therefore molecular weight is, therefore carbon atom is C into X, hydrogen atom is 2 into X, and oxygen atom is X. Therefore molecular weight will be atomic mass of carbon 12, that is 12X, atomic mass of hydrogen is that is 2, and atomic mass of oxygen is 16, that is 16. Atomic mass of hydrogen, therefore 2, number of hydrogen 2, therefore 2X, and it is 16X. Therefore 30X. Okay, the molecular weight of that compound is 30X with respect of X, and by applying vapor density we get its molecular weight is 60. Okay, now we can write 30X equals to 60, therefore X equals to 2, therefore molecular formula of that compound is CH2O whole suffix 2, that is C2H4 and O2. Okay, let's go. Now example number 2, calculate the empirical formula of a compound having the percentage composition of sodium 14.55%, sulfur 20.25%, and oxygen 15.19%. At first we have to divide the percentage composition of each element with their atomic weight. That is, for sodium 14.55 divided by 23, for sulfur 20.25 divided by 32, and for oxygen 15.19 divided by 16. Okay, by dividing we get 0.632, that is also 0.632 and 0.949. Now the smallest number is 0.632, and we have to divide each number with the smallest number 0.632, that is 0.632 by 0.632, 0.632 by 0.632, and 0.949 by 0.632. By dividing we get now 1, 1 and 1.5. In that case one whole number, but 1.5 is fraction. In that case we have to multiply these numbers with such a number that we can get a whole number in the next step. As we can see that by multiplying 1.5 into 2 we get 3. So we have to multiply each number with 2, that is 1 into 2, 1 into 2 is to 1.5 is to into 2. One is to 1.5, that is by multiplying 2 with each number, 1 into 2, 1 into 2, 1.5 into 2, that is 2 is to 2 is to 3. Okay, it is all our whole number, 2, 2 and 3. So we get 2, 2 and 3. So the empirical formula of the compound will be Na2H2O3. Okay. when we get 1.25 or 1.3 or 1.6 or 1.7, then to get nearest whole number we have to multiply 1.25 or 1.35 into 4 and 1.6 1.7 into 3. Okay students, such type of problem if arise, then you have to memorize. Okay, to get nearest whole number you have to multiply 4, 3, etc. numbers with that type of fraction. Okay, molecular formula of an organic acid is CH3COOH. A question: the molecular formula of an organic acid is CH3COOH. What is the empirical formula? Now, total number of carbon in that compound is C2. Total number of hydrogen in that compound is H4 and total number of oxygen is O2. Now, this 2, 4 and 2 simplest whole number ratio is 1 to 1. Therefore, the empirical formula of that compound is C1H2O1, or we can write CH2O. Okay, students? Okay, let's start. Another example, example 4. Find the empirical and molecular formula of an organic compound whose percentage composition of carbon is 75.92%, hydrogen 6.32%, nitrogen 17.76%. Actually, the constituent elements percentage of a whole will be 100%. Okay, vapor density given 39.5. Okay, at first, which step, students? At first, the first step is we have to divide the percentage composition of each element with their atomic number, that is 75.92 divided by 12, hydrogen 6.32 divided by 1, and nitrogen 1776 divided by 14, as atomic mass of nitrogen is 14. By dividing, at first we get 6.33, 6.32 and 1.27. Okay. Now, what is the second step? The smallest number between them is 1.27 and have to divide each number with 1.27. Okay, 1.27. Now, by dividing we get 5, 5 and 1. Therefore, the empirical formula will be C5, H5 and N. N1 or N? C5, H5 and N. Now, vapor density is 39.5. Therefore, molecular weight will be, as molecular weight is the double of vapor density, that is 39.5 into 2, that is 79. Okay, 79. Now, as empirical formula C5H5N, let us consider molecular formula C5H5N whole suffix X. Okay. Now, with the help of X, the molecular weight will be C5H5N whole suffix X, that is C5H5N whole suffix X, that is molecular weight C5X, that is 5X, that is C into 5X plus H into 5X plus N into X, that is atomic mass of carbon 12, that is 60X, atomic mass hydrogen 1, that is 5X, okay, and 14X, that is 79X, okay, 79X. As therefore, we can write 79X is equals to 70. Therefore, X equals to 1. Therefore, molecular formula will be C5H5N whole suffix 1, that is C5H5N. Okay, students? Now, students, it is to be noted that after calculating empirical formula, when we are going to calculate molecular formula, then some informations will be very helpful to calculate molecular formula. Those informations are: number 1, molecular weight is 2 into vapor density. Number 1. Number 2, at STP 1 mole any gas contain 2.24 liter volume. Okay, at STP 1 mole any gas contain 22.4 liter volume. Number 3, at STP 1 mole any compound or element contain Avogadro number of molecule or atoms, such as 1 mole CO2 contain 6.023 into 10 to the power 23 number of CO2 molecules, and 1 mole of oxygen contains also 6.023 into 10 to the 23 number of oxygen molecules, and 2 into 6.023 into 10 to the power 23 numbers of oxygen atoms. Okay, that is it for today. This was all about empirical and molecular formula. I hope this video helped you all. Stay connected to learn more about various topics like it. The next video will be chemical reactions. If you like this video, please do subscribe and like it. Thank you, my dear students.